We are now diving into the topic of security to be in detail, software factory and security, common capabilities for boosting and protecting automotive software business. And we have the experts right here with us to talk about that. We are really happy to have from ITAS, Moritz Minzlaff, Head of Professional Security Services, and Tobias Kreuzinger, Head of Software-Defined Vehicle Product Field Tests. Welcome, gentlemen. So this is your stage.
Thank you, Sarah.
Okay. How are you enjoying ITAS Connection so far? So I'm excited to be on stage with Tobias because software excellence and security excellence have a common root, and we can bring both perspectives to this presentation. I'm going to start with security to talk about security because that's my home turf. And together with you, I would like to consider emergency care for a moment. Emergency care is insightful because here speed is of the essence. Speed is a very critical factor. Minutes decide over lasting damage, right? So you want to be very fast at the scene. And this is similar to security, right? So when there's an active exploitation of vulnerabilities going on, you also want to fix the vulnerability as fast as possible to make your product secure again, to protect road users, business models, customers. Okay? And so recently I read a study that compared communities in Germany, how well they provide emergency care service and the level of care they provide. And it was quite insightful to look at what the more successful communities do differently. So let's have a look at this. First, they have the more successful ones. They have a structured and standardized way of handling emergency calls. They have a software for that to intake all of these emergency calls. And I think we can say this is how they automate things. Okay, so they're automating emergency calls or handling of emergency calls. Another thing they do to reduce time to response, especially in large geographical areas of service, is that they have smartphone apps that connect these emergency calls with trained first responders. Because no matter how many ambulances you have, you're never going to be as fast as someone from the neighborhood coming to the scene, okay? And I think in the IT world, we have another word for this. This is how they scale, right? This is how they scale over a large area, in a large scope. Automation and scaling. Let's consider a third aspect of what the more successful communities that are more successful in reanimating patients, what they do. So when they have a situation, they don't arrive at the scene with one or two individuals. They come with a full team. One for defibrillation, one for cardiac massage, one for medication, you name it. They train for this like a Formula One team does for a pit stop. So they put a heavy emphasis on collaboration, on training this, right? So let's think, and this is, if you take one message home from this talk, from my personal view, add this perspective to you think about security. Let's think about security as paramedic for automotive software. Okay? And with this view, it becomes clear that automation, scaling, collaboration is a common root for security excellence and software excellence. And this is the topic of our talk. And you don't have to take my word for it. So I'm going to have some numbers. This graph shows how competitive automotive companies think they are or view themselves. We have the ones that consider themselves weaker on the left-hand side and those that consider them very competitive on the right-hand side. You can see that there's a slight bias towards the stronger side. So on average, automotive companies think they are more competitive than average. If you're a numbers person like me, come to me after the talk and we have a little chit chat on why there might be this bias. But overall, this doesn't tell us a lot yet. So what I'm going to do is I'm going to break out two segments. And we're going to have the pink people on the left-hand side. It's the lighter color. And we're going to have the purple ones on the right-hand side, the darker color. And here we see a stark difference, right? The pink ones are about average, whereas the purple ones, they are on the very competitive end of the scale. These are the ones that we want to look to and learn from them what they do differently. What are these two segments? The pink ones say they have low cyber maturity, and the purple ones say they have a high cyber maturity. Okay, again, security excellence, software excellence, competitiveness, they seem to have a common root. Okay, so let's dig a little bit deeper. Expectations for technical security solutions. What are automotive companies looking for when they consider, buying, making new technical security solutions? And it's a bit like Family Feud or Familienduell. We have asked 100 different companies, but let's look what they say, okay? Out on top comes meeting regulatory or customer requirements. No wonder. If we don't meet customer requirements, regulatory requirements, we're not in business. Okay? Next up, reduction in cyber risk. Okay, this is interesting. This is a quite different thing. And I'll come back to that in a minute. And there's a couple more things: ease of integration, future-proof protection, certifications, and cost. Of course, cost is always a factor. Okay? We said we want to learn from the purple ones, from the purple companies. So what I want to do now is look at where the pink ones and the purple ones have the biggest differences. Okay? Where do we see the biggest drop? It's with cost. Okay? So the pink ones with lower cyber maturity, who are about average in competitiveness or consider themselves about average, they put a higher emphasis on cost than the ones with higher cyber maturity. Okay, it's still a factor, obviously, but where do we see increases? Where are the biggest increases? They are with reduction of cyber risk and future-proof protection. So it seems that the purple companies with a higher cyber maturity, that they're asking a different question. They're not asking, what does it cost, but what do I get? Okay, and I think this rhymes a lot with the tagline we have at Ethos for our security solution field, where we say reduce risk, increase potential. I think it's a very similar mindset and way of thinking about security. I like it a lot. All right, one more slide from my side, and we're coming full circle now. This is showing adoption of DevSecOps practices within the industry. Okay, so we have cross-team collaboration, we have automation, and treating security as code. And you can guess what I'm going to do next. Okay, I'm going to break it out into the pink and the purple. And what do we see? Across the board, we see a higher adoption of collaboration, automation, treating security, a quality aspect of software, right, as code. We see a higher adoption of this with a higher maturity companies. Cybersecurity as paramedic for automotive software, right? These companies, they will be faster in rolling out patches when there is a vulnerability. They will be faster to fix exploitations and to keep their product secure. And of course, the same capabilities will also speed up releasing new software for new features, for the next product upgrade. And here we are at Software Excellence, and I'm going to hand over to Tobias.
Thank you, Moritz, for the insightful discussion here. So, bring this a little bit into context. When we look at the complexity that needs to be dealt with, we heard it this morning in the presentation of Thomas. There is this heavy burden for this poor person who has to do the single point integration of all these software artifacts in the software stack. Yeah? And we learn from our customers, typically in the traditional way of working, this takes 5 to 6 months to do a full-blown certification software test on such a stack. And we also know from other customers that they want to deploy a full stack in a matter of 12 to 14 months. So you have exactly 2 shots taking this burden down to the road while maintaining security measures in the software stack, in the device, in the vehicle afterwards. But not only there, also in the development infrastructure. And this is a massive challenge. And the way to compete with this challenge is really thinking on how you can further accelerate pipelines, how you can improve reactivity and speed. And there's some hurdles to be overcome in terms of multi-supplier handling in such stacks, dealing with the legacy that you bring into the stacks, and new technologies where you have to also ensure security. Yeah? Looking at SDV, there's new interfaces to the device which need to be protected. Now, and I'm sure you have seen these as major contributors to speeding up things in the development cycle. It's virtualization, automation, scaling, and collaboration. And you have heard this earlier in the talk, that this is exactly also in the DevOps principle, the keys and prerequisites to really have a speedy deployment of software. And the key thing here is that not only once you have those implemented in your pipelines, in your development setup, you start thinking about security. You do it from the very beginning in each and every of these steps. And to visualize this a little bit more concretely, what this actually means, we wanted to bring such an example here of a software build and a security testing pipeline, where you go from the very left side here, from software development, where we typically perform already in these stages threat and risk analysis on the software stack, then going through the software generation, unit testing, static code analysis, but also something like source code fuzzing, to stimulate the software functions and identify vulnerabilities throughout the process. Then we go further down, generate the code, hex file, deploy this on the controller, integrate this in a testing environment, either hardware and loop system or in the vehicle, and then further impose test cases onto this environment. And in the context of security, here we would impose things like a protocol fuzzing, where we basically stimulate the buses and the different ports of the device to identify vulnerabilities in an arbitrary manner on the controller, perform the execution, and then perform the analytics to identify what of the test vectors cause the ECU to break, or which of the test vectors really enable the software to pass. Now, this is the base way of testing that we see with many of our customers today, and there's further means of acceleration, as I mentioned on the previous slide. Of course, there's something like configuration management system and dependency tracking that we need to perform more efficient debugging, have a proper traceability in the code, but also, of course, adding automation in the topic of virtualization, where we abstract the software and the hardware in a way that we can really bring the entire test system into a virtual environment and then perform the exact same security tests that we did in the vehicle or in the hardware in the loop system, also along the testing pipeline in the virtual environment. And then, of course, you can also put in certain learnings. We have heard in the morning that there's also AI involved in improving tests. Those tests where things failed can be redistributed back into the virtual environment such that the overall test campaigns increase, and you have an ever better check of your security in the vehicle. But this also means there's more test cases to be dealt with. And here the topic of scaling helps. So bringing things into the cloud, parallelizing test cases, and then ultimately, when it comes to cross-company collaboration, also topic of collaborative debugging in a collaborative environment further speeds up reactivity on certain vulnerabilities. And especially if we think about cloud and a collaborative setup, the topic of vulnerability and incident management system is a very important one. So it's not only about security of the device, but even more and more also about security of the entire development infrastructure. One last thought here I want to share is an activity that we drive together in the open source context. Also this morning we have heard about the power of open source. We together are also engaged here in a small project, OpenDUT, Open Device Under Test, where we follow the idea together with some industry partners to basically abstracting the different test automation tools, testing tools for security testing, either open source or proprietary test tools from the actual devices under test, which may be even in earlier stages distributed across the players collaborating on the software. So this interim layer, we consider it as a non-differentiating layer. That's why we put it in an open source context. and jointly work here with OEMs and a couple of other industry partners to enable this standard interface, and with this also enable cross-company testing, such that, for instance, test cases and test tools being implemented in one OEM can be deployed through this interface into the actual device under test at a tier. Yeah? So with this, we want to conclude the talk. There's a couple of key takeaways. If you want to take things with you today, you've heard about the joint root of software excellence and security excellence. If you look into the details, things really go together, and things really have to start from the very beginning to be really excellent and reactive on the functional software testing, but also on the security software testing. And the key steps here to optimize software performance is virtualization, automation, the collaboration, and of course also cloud-based scaling. And ultimately, we know that our different customers are at different stages in this journey towards a fully performant software development factory. And the point that we want to make here is that may it be software development speed, but may it be also the security, we can give you a good contribution and take this journey together with you, and also give guidance where we can start and how we can improve your overall software development efficiency.
Thank you.